In this video, we're going to go over integration by parts. Integration by parts is really the reverse of the product rule. Integral u dv is uv minus integral v du. Let's go over a proof. So we'll start with the product rule. d dx of u of x times v of x. Applying the product rule, we get u prime of x times v of x plus, keep u of x the same, and differentiate the second term, v prime of x. Now let's integrate both sides with respect to x. So we have integral d dx of u of x, v of x, dx. That's equal to integral u prime of x, v of x, dx, plus integral u of x, v prime of x, dx. Now integral cancels derivatives. So on the left hand side, we just get u of x times v of x. That's equal to integral u prime of x, v of x dx, plus integral u of x, v prime of x, dx. Let's rearrange this expression so we can obtain the formula. So I'm going to solve for this term. Integral u of x, v prime of x, dx is equal to u of x times v of x minus integral v of x, u prime of x, dx. Now, if we suppress the variable u, what we really have is integral u dv is equal to uv minus integral v du. So you can see that this part, this is just u. If we suppress the variable x, v prime of x dx, this part is dv. Now here we have u times v, and here we have v, and u prime of x dx, this is just du. Alright, so now this is the integration by parts formula. Let's talk about a definite integral. So if we have limits, integral from a to b, u dv, that's equal to uv from a to b, minus integral v du, and the limits of integration are from a to b. Now applying the fundamental theorem of calculus, we get u of p, v of p, minus u of a, v of a, minus integral a to b, v du. So that's the result for the integral a to b u dv. It's important to realize that this part of the equation is already integrated. And so we just have a simpler integral to solve. And if it's done, if the choice of u is done properly, this integral will be easier to solve. Alright, so our strategy here is to choose u easy to differentiate and choose dv easy to integrate. If both u and dv are easy to differentiate and integrate, then choose u to be the polynomial. For example, choose u to be x or u equals x squared. This strategy will work most of the time. So a similar strategy is a light principle. And L stands for logarithmic functions. Example, u is equal to ln x. I stands for inverse trig function. Example, u is equal to sine minus 1x. And A is for algebraic functions. So example, u is equal to x to 1/2, or u is equal to x squared. And T is for trig functions. For example, u is equal to sine x, or u is equal to cos x. And E is for exponential functions. For example, u is equal to e to the x, or u is equal to 2 to the x. So choose u to be the function that comes first in this list, in this light list. Alright, we're going to look at an example. So here we have integral x e to the 2x dx. So this part here is going to be u, and e to the 2x dx, this part is dv. All right, why do we choose that? Why do we choose u to be equal to x? Is because if you look at the light list here, you can see how x is an algebraic function, and that comes first on the list. E to the 2x is exponential, and that comes last on the light list. So the first choice for u is x. So we let u be equal to x. Its derivative du is equal to dx. dv is the leftover. So if you choose u equals x, then whatever is left over has to be your dv. So in this case, that's going to be e to the 2x dx. So dv is e to the 2x dx. How do we obtain v? V is going to be the integral e to the 2x dx. And what is the antiderivative of e to the 2x? Well, that's going to be e to the 2x divided by 2. And notice that we're applying the substitution rule, namely letting u be equal to kx, and du is equal to k dx. But because it's an easy substitution, we just do it mentally. All right, so now let's apply the formula. Integral u dv is equal to uv minus integral v du. So integral x e to the 2x dx, that's equal to u times v, that's x, times e to the 2x divided by 2, minus integral v, which is e to the 2x, divided by 2, times du, that is dx. 1/2 is a constant, it passes through the integral, so we get x e to the 2x divided by 2 minus 1/2 integral e to the 2x dx. We already solved this integral when we had to obtain v. When we integrated dv, we integrated e to the 2x. So we already know this result. This result is just e to the 2x divided by 2. So what we have is x e to the 2x, integral x e to the 2x dx is equal to x e to the 2x divided by 2 minus 1/2 integral e to the 2x dx. And we know how to integrate this. That's just e to the 2x divided by 2. Let's put a negative 1/2 in the front. Put brackets here. We have x e to the 2x. Let's rewrite that. And let's rewrite the left-hand side as well. X e to the 2x, integral of that dx. So always add c. So the result is integral x e to the 2x dx. That's equal to x e to the 2x divided by 2 minus 1/4 e to the 2x plus c. This is the antiderivative. All right, thanks.